In this video, I want to take a closer look at polyatomic ions and teach you some of the patterns that they happen in. Many teachers are going to ask you to memorize all of the polyatomic ions. With my point of view, when we use them enough, we kind of learn them in spite of ourselves, just like we learn each other's names in the classroom because we use them frequently. There are only really a few that you should memorize. After that, the rest of them can be figured out because they follow patterns. One of my favorite tricks for memorizing the polyatomic ions is this phrase: Nick the camel ate clam for supper in Phoenix. This particular phrase will tell us the H version of the 5 most common polyatomic ions. In order for us to use this, we need to understand the difference between consonants and vowels. The consonants are going to tell us the main element in each of the first consonant is going to tell us the main element in each of the common polyatomic ions. It will also tell us the number of oxygen atoms. The vowel is going to tell us the charge. So for example, in the word Nick, we're going to start with nitrogen. The first consonant tells us the main element. Because there are 3 consonants in the word Nick, I'm going to put 3 oxygens. Because there is only 1 vowel in the word Nick, I'm going to give it a charge of -1. These are all 8 ions, so this is the formula for nitrate. In the name camel, C gives me my main element carbon. There are 1, 2, 3 consonants, so I need 3 oxygens. There are 1, 2 vowels. The charge is -2. These are 8 ions. This is carbonate. Now we've already used C for carbon, so in this case we're going to use Cl for chlorine. There are still 3 consonants, so I need 3 oxygens. There is 1 vowel. We need -1 as a charge. This is chlorate. Again, these are the 8 versions of the ions. In the word supper, S stands for sulfur. There are 1, 2, 3, 4 consonants, so I need 4 O's. There are 2 vowels. The charge is -2. Because this is based on sulfur, this is the formula for sulfate. And P in the word Phoenix stands for phosphorus. There are 1, 2, 3, 4 consonants, so I need 4 oxygens. In the word Phoenix, there are 3 vowels. The charge on the word Phoenix is -3. So this is from phosphorus, phosphate. So by recognizing consonants and vowels, I now have 5 different polyatomic ions that I know all end in the word 8. Nitrate, carbonate, chlorate, sulfate, and phosphate. Let's use these as the starting point to show you how we can derive the other ions from this point. Many families, most notably the halogen family, group 7, actually allow us to substitute one halogen for the other with nothing else changing. For example, from our list before, we know that ClO3 with a -1 charge is chlorate. By substituting the chlorine for an iodine, nothing else has changed. I still have 3 O's. I still have a charge of 1-. Instead of chlorate then, this becomes iodate. Or substituting everything exactly the same except a fluorine, fluorate. And substituting with bromine, bromate. In each case, you will notice 3 oxygens and a charge of -1. So if I know 1 halogen compound, I could substitute another halogen in its place to get several other different atoms. Another common trend we notice with the polyatomic ions is the name ending. Again, I'm going to use chlorate as a starting point. So we know chlorate from our Nick the Camel analogy. In this example, what we're going to change is only the number of oxygens. By removing just one oxygen and having ClO2 instead of ClO3, my 8 becomes an ite. This is chlorite. If I remove one more oxygen still, it will throw off another oxygen. I have ClO1, still a charge of -1. This is hypochlorite. Hypo means low. It is lower than or one less than the number of oxygens in chlorite. We also could take my starting point chlorate and add an oxygen. So I now have 4 instead of 3 oxygens. Again, my charge stays the same. In this case, we have one more oxygen, the 8, so we use the prefix per chlorate. This works for any of the elements we know. So for example, if I have SO4 with a -2 charge, from our analogy, we know this to be sulfate. Removing one oxygen, SO3, and keeping the charge the same at -2, this is now sulfite. Removing one still, SO2 -2, we have hyposulfite. And in the other direction, adding one more oxygen still, we would have persulfate. So this pattern can be used for any of the 8 ions that we saw in the Nick the Camel analogy, also for any of the derivatives we learned by substituting the halogens. In grade 11 chemistry, you're not asked to know the common versions for acid naming. When hydrogen attaches to those polyatomic ions, or even to a monatomic ion, it forms an acid. An acid is any compound that starts with hydrogen. Acids all have binary names, but acids also have common names based on the type of ion they're attached to. So for example, when hydrogen attaches to an 8 ion, suppose I add hydrogen to an SO4 -2 group. This is hydrogen and sulfate. We get H2SO4, and it would be very correct to call it hydrogen sulfate. But there's a common naming that gets used for acids, and because it ended in sulfate, we can call this sulfuric acid. Eight ions become ic acids. If the hydrogen had attached to sulfite, again, doing my crisscross, I get H2SO3. Sorry, sulfite, I'll make that an SO3. It is correct to call this hydrogen sulfite, but the common naming says we can replace ite for us and call this sulfurous acid. Hydrogen can also attach to monatomic ions. Hydrogen could attach to chlorine, HCl, called hydrogen chloride, or to sulfur, H2S, because of the -2 charge on sulfur, hydrogen sulfide. And at grade 11, these names are considered acceptable. However, they also have common acid names starting with hydro, and then we put the root word ic acid. So HCl is hydrochloric acid. H2S would be hydrosulfuric acid. Notice the difference. Sulfuric acid is H2SO4. Hydrosulfuric acid with the prefix hydro is simply H2S. When we see the prefix hydro, it means that the anion, the negative half, was monatomic. It was just a single element that had become an anion. Now, I show you this because we will see the common names throughout the use in chemistry in grade 11. But you are always welcome to use their regular binary name based on ionic and covalent rules that I have taught you. To practice our naming skills for ionic and covalent names and formulas, continue to work on the assignment I gave you in our last lesson on naming ionic and covalent formulas. You may also work on the worksheets found in your green work booklet on pages 22 to 29. These have been broken down into sections to help you practice each scale separately, with the last two pages, pages 28 and 29, being mirror images of each other that you can use to practice these in a mixed format.